Just a quick recap here. Tolerance, right? It's the variation allowed for something to still be acceptable. One way of looking at it. The other way is right here, the range of acceptable values, right? The range of acceptable values, that's another way of looking at it. But as a specific example here, that in this case, the tenon, right? The tenon needs to be small enough to fit, but large enough that it will not fall out, right? That's like a specific example of what we mean by tolerance. Tolerance, mathematically, it's calculated by subtracting the greatest and the lowest value that of allowed measurements. And we have 4 ways of stating our tolerance. I would strongly suggest you put this on your study sheet. Okay, just the format so you know that if I give you a certain one, you can associate it with a specific format and you know what the numbers represent. Like for example, this 4 millimeter, if you look at your study sheets, like, okay, that's my tolerance, right? So you have that. Now we're going to go to page 94. There's a blank page there, and I just need you to fill in some of the notes that I'm going to give you. Okay. Here's tolerance one more time. Range of acceptable values. Sometimes it's the range of values that will still allow that piece to be used for its intended purpose. Right? But another way is to talk about it, items measured. This is on page 94. Items measured that fall within the min and max. But I will say inclusive. What does that mean? That means that if it's right on the inclusive. Yikes. Anyways, it says inclusive there. Inclusive. Items measured that fall within the min and the max, inclusive, so like it could be exactly that number, will be accepted. It will not be discarded, it will still be accepted. Let me just focus one more time, it seems a little blurry to me. So example, let's say it doesn't matter what industry, let's say we're making washers for bowls, right? And the thickness of these washers is you're allowed to be anywhere between 1.7 millimeters and 2.1 millimeters. And let's say you're taking samples, random samples of the production line. So let's say you have sample 1. Let's say you pull it and it's 1.64 millimeters. Next sample, okay, let's say it's 1.702 millimeters. Sample 3, let's say it's 2.101 millimeters. And the last sample, 2.1 0.05 milliliters. So you're taking samples, you're measuring them, and you need to know, am I going to throw it out or throw it back in the bin to reprocess, or do I keep it? So 1.64 millimeters, focus on the 6, right? It's lower than your minimum, right? This, right, is lower than the minimum acceptable value, so this one would fail. This would not pass the test. What about sample 2? Did that pass? If it's on this or greater, you're fine, because this is the smallest thickness that is allowed to have, and it's actually a little bit bigger. So in this case, check. This case, it's a check. On the other hand, here, sample 3 is 2.1, so you're like, oh yeah, that's right there, but it is slightly bigger than 2.1. It's slightly bigger, so this would technically fail. According to this tolerance here, it will fail. And then sample 4 is 2.05. It's somewhere between here. It's closer to 2.1, a little smaller, so that one would pass. But here's what I tell my students to do this when you're not sure. Like let's say this one has 3 decimals. You can write this as 1.700, right? You can as 700. And then just look at, this is 702, right? It's a little bit bigger than this, which is allowed. Like this is the lowest you can possibly get. This is the highest you can possibly get. So anything in between or right on it is fine. Right? So sometimes it's better to write it and just tack on a few zeros past the decimal. Okay. Okay, I'm going to cut that right here. That's that for, because there will be a question here and there asking you to tell me whether or not it will pass. It would be accepted for its intended purpose, right? Given the tolerance here. Okay, next, let's do some examples. Real life examples. You need to have a few. Prescription drugs. So when I ask you, hey, like how would tolerance be used in this case when it comes to prescription drugs? So you have to talk about what happens when it's too low and what happens when it's too high, right? I will say this. Dosage has to be high enough to have the intended effect. So it has to be high enough to do something. Like if I take 1 Tylenol, I'm a big guy, it's not going to do anything for me. I need to take 2, right? My kids, right, they take 1. Right? So the dosage has to be high enough to do what you want it to do, but it has to be low enough, but right, low enough to prevent an overdose. Okay, you want to prevent an overdose. So again, we're talking about, right, high enough, low enough, right? You're talking about a tolerance. Like if it's too low, it's not going to have its intended effect. If it's too high, you can possibly overdose, right? So or have serious side effects, right? So the next example is electricity. This is the last real life example I'll give you. Okay. Voltage has to be high enough for the equipment to function. It has to be high enough for it to even turn on. If the voltage is too low, like your batteries, you know why they die? Like they die because the voltage slowly decreases. So if I have like this 9-volt battery here, I measured it a while ago, it's supposed to be 9 volts. It's probably more like 6 right now because it slowly depletes, right? So, but it has to be high enough for the equipment to function, but okay, low enough. Sorry, low enough to prevent a surge or prevent equipment from frying. Right? You don't want to fry, that's what we call it, like in electricity, right? In the electrical world, if you fry something, it's a bad thing. If it comes to food, it's a good thing, right? But you don't want that. And when it comes to electrical components, you don't want to fry anything. So when you're not sure, don't plug it in, right? If it's a can't take it, don't plug it in. Okay. So cut that there. That's just your real life examples. I will not reteach this next week. Okay. You get this. And I may or may not post this video today. Maybe there'll be a glitch, right, in the system. There you go. Next, uncertainty versus tolerance. Uncertainty versus tolerance, because some students think they're the same thing. So, whoa, what happened there? Tolerance. Uncertainty, okay, it's caused by the limitation of measuring device. And that's the precision, right? It's also known as the margin of error. Like margin of error is like how much can you be off by? How much can a certain measurement be off by? And I didn't see this until recently. I might get a beaker. Actually, a beaker says plus or minus 5%, like that volume that you have, 100 milliliters and so forth. It says it at the top, plus or minus 5%. You could be off by 5%. That's interesting. Versus tolerance. So uncertainty is something caused due to the limitation of the device. Tolerance, okay, limits the range, right? So tolerance arrow, right, limits the range of acceptable values. So we kind of talked about it, but what is that due to? Due to various aspects. It could be a human error, right? When you're producing something and you're not calibrating your machine just right. It could be equipment, right? Equipment malfunction. Precision limits. etc. So who sets the tolerance? The industry does. Who sets the uncertainty? The measuring device. I don't know if that makes sense. Maybe I just thought of it now, so I'm going to add that. Sorry, guys. Where will it fit here? Set by industry. That is the key here. Set by industry. This is, I'll just say that, set by device. Just something catchy, right? Some catchy phrase maybe. Uncertainty is set by the device. Tolerance is set by the industry that you're working in. And it is also partly due to the device, but not just by that. Okay? It has to do with money too. If you throw out too much, you're going to lose money. So you're going to allow for some variance there. Okay. And so the last piece on the back side, I'll give you one example. I'm a little over, I know. Probably thinking, why? Okay, why did I come to school today? Well, I commend you for that. See the bottom of page 95, the bottom of this little gray box, that's where I would cut it right there. Okay, so at the top we can use for that example at a later date, and this we can use today. Okay, so we'll copy this. Given the following tolerance, okay, so given the following tolerance, stated in 3 other forms. Stated in 3 other forms. Well, we'll just go with A here. 5.2 volts minus 0 volts plus 1.2 volts. Write that down. So you have your study sheet. The 4 formats are on page 92. So you go and look at this one. Is there, okay, that minus 0. Okay, let me see here. Which one? It's this one here. This one that has minus 0 at the bottom. So this is what I'm after here. So I'm gonna say, okay, I found it. It's really saying min minus 0 plus tolerance, right? So I'm just gonna box this in. This is the one that I'm given. This is the one that I'm given. So there are 3 other forms, right? There's this one, and this one, right? So this is given. I'm gonna write it in these other 3 forms. So this is the key. This is how you do it every time, guys. I did this yesterday already. Max, min, tolerance, and nominal. If you can, and you can, I promise you can extract these 4 every time, every single time. I promise, that's my promise to you. So the first one is the nominal. In this particular case, it is the big number up front. That one right there. So fill that in. Nothing to it, right? The other one, I would like you to do the max and min first before you do your tolerance, just because that one oddball there. So to get your max, you go 5.2, right? This one, plus 1.2. That's how you get your max. You add, if there's anything to add, you do it. So it's 6.4 volts. The min is this minus 0? You're like, well, Mr. Dirksen, really? You're going to actually do this? Yeah, because it might come in handy later on. Like this might not always be 0, okay? So then you're like, okay, got it. And tolerance, I don't know if you remember, it's always max subtract the min. It's always subtracting these two. So 6.4 minus 5.2 is 1.2 volts, which is right there, which you knew was your tolerance. But this is the fail-safe way to do it. And I will kind of cloud this in because this is not the answer. This is just what you need to come up with the answers. Okay, so the other formats in no particular order is like this. There's one that wants you to write it like this. There's one that wants you to write it like this, nominal, plus or minus, and you don't have to memorize these. Just go ahead and look it up. Right? That's the other one. And the last one is this one, max minus tolerance plus 0. These are the three other ones that we want. I'm going to box them in because it's kind of like nice to see that these are the other three we want. So now it's just a matter of drawing your information, right? Max, min, they're right here. So 6.4 volts and min is 5.2 volts. You're done. Next one, it's calling for nominal, which I already have. So it's 5.2 volts plus or minus 1/2 of my tolerance, right? That calls for tolerance. Tolerance is right there. So it's 1.2 volts. Just leave it like that. And the last one calls for max, which is 6.4 volts. That's from my inventory here. Plus 0 volts minus whatever the tolerance is. It's right there. It's 1.2 volts. Voila, right? So once you have this, once you have these four pieces, you can go and rewrite it in all the other three in this case, formats. And if you want to practice this right now, you got to go to the workbook. There's a tolerance worksheet there. And you're doing this kind of stuff there. And so that's it's after page 11. Because that one doesn't have a page number. It's technically supposed to be 12 and 13. 12 and 13 is where you would find this worksheet. Thank you guys. I went over, I know.